I often get asked, when is the next killer asteroid coming? Once they know I'm an astronomer, they want to know when the world's going to end from an asteroid or comet impact. My answer, kind of tongue-in-cheek answer to that, is that we get hit by asteroids every day. The good news is that most of those asteroids that we get hit by are about a centimeter or two across, so they're just burning up in the atmosphere. The real massive civilization-ending impactors that probably wiped out the dinosaurs, those happen about once every 100 million years. My name is Nick Moskovits. I'm an astronomer here at Lowell Observatory, and I specialize in observations and simple models of small bodies in the solar system. So that means I study comets and asteroids. In particular, I spend a lot of time looking at near-Earth asteroids and main belt asteroids. We know that a lot of the materials that are here on Earth that make it possible for life to emerge, water and organics, those are found out there on asteroids. There's lots of evidence that suggests that those materials were not intrinsic to the Earth when it first formed, and that asteroids actually delivered that material to the Earth.
Because asteroids are so old, they offer an unprecedented look back into the history of our solar system. To answer questions like, could the building blocks of life have been delivered by an asteroid billions of years ago?
If we go out onto the surface of the Earth, for example, and try to study what was happening 4 billion years ago, that would be very difficult. And that's because the Earth has weather, it has wind and rain, it has plate tectonics, and all of these things effectively act to reset the surface of the Earth. Going out and, say, picking up a rock, chances are that rock is not going to be very old. Asteroids, on the other hand, don't have weather, they don't have wind, they don't have rain, they don't have plate tectonics. So they've remained pristine and primitive over 4.5 billion years.
4.5 billion years ago, most rocky bodies floating around in the solar system accumulated to form planets. Asteroids are the leftover material that didn't. Dr. Moskovits wants to know what asteroids can tell us about where we've been and where we're heading. Moskovits uses the DCT's Large Monolithic Imager, which is similar, say, to the CCD chip inside your camera phone, if your camera phone was sensitive enough to capture the faintest objects in our universe.
We now know of over 700,000 asteroids. There are far more asteroids than anything else in the solar system. And we're continuing to discover hundreds and thousands of them every month.
Dr. Moskovits' latest project is aimed at selecting from all the asteroids discovered each month the most interesting ones in terms of sending a spacecraft.
And that could be a manned mission, it could be a robotic mission, it could be a flyby mission, it could be a lander, it could be asteroid mining, whatever scenario you're interested in terms of sending a spacecraft to one of these objects, we can provide a data set through this MONOS project that will help you down select to the targets that might be best for your mission.
Using a large telescope like the DCT, Dr. Moskovits has discovered all kinds of near-Earth objects. But what about potential impactors? Asteroids that could be on a collision course with Earth.
So it's relatively recent, and recent I mean sort of early 1980s. It was begun to be realized that the dinosaurs may have been wiped out by an asteroid impact. And the biggest evidence is a large impact crater that's just off the Yucatan Peninsula in Mexico. What we can do is we can look at craters of that size and say, okay, well here's one in Mexico. Where else do we see craters of that size? And there are a handful of them on the Earth. There are a handful of them on the Moon and other bodies around the solar system. And we can start to try to date those craters and say, okay, well the one that killed off the dinosaurs was 65 million years ago. The one that's over there on the Moon is 200 million years ago. The one that's over there on Mars is 300 million years. And we can start to build a record of how often objects in the solar system get hit by objects that are large enough to produce these massive impact features. I think on the most dramatic level, we are studying objects that can and do impact the Earth. And so by studying these objects and understanding where they are and when they're going to impact, we could do something about that and literally save the Earth. So that's an important reason for studying these objects right there. Maybe just be those two. It's a pretty sparse build, it's not a
Because Dr. Moskovits can't possibly stay up every night to keep an eye on the sky, he built 2 meteor fireball camera networks to triangulate the path of incoming meteors.
This is the location of one of the LOCAM's meteor fireball camera stations. The cameras are up on the roof of this building. In that box up there, there's 16 cameras that are all pointed to different parts of the sky. And by the time I'm up the next morning, I have a list of detections that the cameras have made each night. And in a given night, these little cameras that we have on sky are producing hundreds of detections of meteors, which is kind of amazing.
If you see a shooting star in the sky tonight, remember, you may be looking at a 4 billion-year-old rock burning up in our atmosphere.